Hello everyone, my name is Paras Pundia and I am the program manager for Reactor Bangalore, which is a global program for communities. And we have been hosting these Azure Happy Hours from past 4 months almost, and we have hosted like some amazing live sessions. Last Azure Happy Hour was with Frank, and he was talking on Azure Serverless, and the session people just loved it. And similarly, to keep the momentum and keep up the energy, we have called up Dave. He's coming live for us from Sydney, Australia, and bringing all the knowledge he had been in such a small session for all of us. And yeah, you will be listening to him. So keep your cameras off and keep your mics mute as the sessions which has been played in the screens, and make sure that if you have to ask a question, you can put it down in the chat section. We have Himanshu Beniwal and Kunal Gehlot, who are the MSPs, those who are helping us in organizing this and managing this. They will be taking care of these questions as well all together. So stay hold and keep your questions. Let's try to make this more interactive once we are done with the Dave session. And I really want you people to make the most of your time. Don't be like that it's a monologue and he'll be just speaking and you guys just take the knowledge and fly away. Don't fly. Stay, hold, and learn most out of it. He will be here to answer your questions even later in the chat section. Also, that's the reason we have picked up Microsoft Teams, and you will be able to talk to him later as well. So yeah, I'm giving it over to Dave now, and we are ready to go. Dave, to you.
Hey, thank you very much. I'm just going to bring up my slides. Just bring that up. Just share my desktop, sorry. Right, so hopefully you can see my desktop. And hopefully you can see my slides. Can you give me a thumbs up just to make sure that's really the case? So give me a thumbs up. Okay, so hey, welcome everybody. So my name's Dave Glover, and I'm a cloud developer advocate at Microsoft. And I have a focus on the Internet of Things. And as was mentioned before, I'm based in Sydney, Australia. Now, I've also got a guest who's coming along. His name's Peter McAlpine, who's the operations director for a Sydney-based company, or Australian-based company called Divvy Parking. Now, I have to confess, I've actually got a recording. So he actually did a recording for a couple of days ago, which I'm going to include in this session. And the other thing about this session, it's going to mirror the content that you will find at the Azure Sphere Developer Learning Path. So you'll see there's a link down the bottom there called aka.ms/Azure Sphere Developer Learning Path. So just keep an eye out for that as well, because you'll find way more detail than really what I'm going to go into, just because of time constraints. So the first thing I want to talk about is just the agenda. So I'm going to do an introduction to what Azure Sphere is. Now, I'm assuming most of you appreciate this is an Internet of Things session, and so this is going to be, so Azure Sphere is kind of a device in the Internet of Things environment. And there's going to be a talk from Divvy Parking, who's just going to talk about their implementation of a secure parking solution. And as part of that solution, they actually went and used Azure Sphere. They actually use Azure Sphere as a secure way to open the boom gates in a car park. So you know the boom gates when you want to drive in, well, they've got a mobile app, and you go and basically click a button, and if you've authorized, it'll open up the gates. And then finally, what I'm going to do is a demo of just how to go and build an Azure Sphere application. Now, so as was mentioned a couple of times, please put in questions in the Q&A. I actually can't see the Q&A at the moment, but I will obviously when we kind of break for a bit. So the first thing I want to talk about is just kind of the Internet of Things and security. And if you think about IoT, it opens up an enormous opportunities to really change our lives, our businesses, our communities, our governments, and things like that. But I think most people appreciate it's also connectivity is very much a two-way street. Oh, I think we've got someone with a microphone going. I can hear someone's microphone going somewhere along the line. Quite sure what's happened there. Okay.
I think we are fine.
Okay, that's cool. Sorry, I could just hear a lot of noise. So if you think about the Internet of Things, it's an enormous opportunity, but as most of us have been in this area for a long time, will appreciate that it's a two-way street, and connectivity is a two-way street. And we can go and build our products, but hackers are a pretty creative and determined bunch. And we may find they're using products in the way that we don't really intend, is a kind of the guts of it. And really, a day goes by without something in the news, particularly the technical news, about an IoT security vulnerability or that something has been hacked. If you have a hunt around, you'll see plenty of things like the examples that spring to mind that I've got in my notes. And things like baby monitors have been taken over by hackers. You've got toys that suddenly are spying on families. I recently read one about a robotic vacuum cleaner which had a camera on it, and that camera could be operated by people outside of the home. We've had heart pacemakers and cars hijacked. We've had cities hijacked. So I think probably most people appreciate that the issue with security is probably the number one issue that's facing the Internet of Things and the whole industry. So the next thing I want to talk about is approaches to mitigating security. So the first thing I want to get over is that security is very much a journey. There is no one size fits all. There is no one solution that will suddenly make everything secure. It's very much about a journey. It's being about agile and being able to understand what the new attack vectors are. So the thing about security, it's really difficult to get right. It's complex and it's very expensive to get right. But most importantly, out of that, it's ongoing. So there's always something new. There's always a new approach to hacking into systems. And as I'm sure you appreciate, Microsoft's got a long history of building secure systems. Some of that has been difficult at times, some of it's been quite checkered. And it's those lessons that we have learned when building secure systems that connect to the internet. We're taking those lessons and applying them to Azure Sphere. So Microsoft and the industry have identified 7 properties required for highly secure devices. Now, again, it's not my intention to go into all of these in detail, or any particular detail for that matter, but down the bottom of the 7 properties.
Okay.
And so I would thoroughly recommend checking out that link, and you'll get a whole lot more detail. But I'm just going to touch on a couple of things. So, for example, a hardware root of trust. That's really around a device has an unforgeable set of cryptographic keys. You've got things like error reporting. So if a system's being hacked, if you don't have error reporting, then you don't know a system's been hacked and you don't know how to mitigate against it. And things like renewable security. You need to be able to refresh certificates, you need to be able to refresh the operating system, and you need to be able to refresh the applications. And I said, I'm not going to go into this any more detail. Go and check out aka.ms/7 properties, and you'll find a wealth of information that kind of goes into that in a lot more detail. So the next thing I want to talk about is Azure Sphere. So Azure Sphere is made up of 3 components, which together implement those 7 properties of highly secure devices. So the first one is silicon. So there is an Azure Sphere certified microcontroller, which also contains a hardware root of trust. Now, that bit of silicon is a multi-core microcontroller. It's connected multi-core microcontroller. And it is capable of running real-time applications, as applications which, for example, require very precise timing or very deterministic timing, as well as high-level applications. And I'm going to touch upon that in a bit more detail shortly. The second component of Azure Sphere is this thing called the Azure Sphere operating system. And that is something that basically runs the platform or runs the device. And it's something that we will also maintain. So we're going to provide ongoing updates to the operating system for Azure Sphere. And the third component of Azure Sphere is as a cloud service called the Azure Sphere Security Service. And it has a number of responsibilities, including things like brokering trust, detecting emerging threats, app reporting, sending down operating system updates, sending down your application updates. So being able to do things like over-the-air updates. So the important thing about Azure Sphere, it's those three components that together implement the 7 properties of highly secure systems. So what I want to do now is just touch upon the hardware ecosystem for Azure Sphere. So the first thing up here is, I'm just going to change the pointer. The first one up here is the Azure Sphere certified microcontrollers. Now, today, there is one manufacturer, one silicon provider who is building Azure Sphere certified microcontrollers, and that is MediaTek. And they have something called the MT3620. Now, we've also made 2 additional announcements with other silicon partners. One is from NXP, and the other one is from Qualcomm. And Qualcomm are going to be doing a cellular-enabled Azure Sphere solution. The next kind of layer on this is the development kits. Now, development kits are great for prototyping. So if you've done anything with Arduinos or Grove boards or things like that, you kind of get this. But these are boards where you makes it very simple to basically plug in sensors and actuators and relays and switches and things like that onto these development boards. So you don't have to get out a soldering iron. You can just basically plug in sensors. So we've got boards here from Avnet. So the one where the mouse cursor is now is called the Avnet Azure Sphere Starter Kit. And it supports these things called click boards from a company called Micro, I think they're called. And they're about, I think close enough to 150 of these click boards that you can click onto these Azure Sphere devices, boards. Seed Studio also have 2 development kits. They have the original, what's called the reference design board, and they've just recently brought out another prototyping board called the Azure Sphere Mini Kit, and it's just a cheaper price point as well. So the development kits are great for prototyping. The third layer on this is modules. Now, if you are in the situation where you want to go and build a solution, then the strong recommendation is you go and take an off-the-shelf module. And these are manufactured by people like USI, we've got Avnet, and we've got AI Link. And the idea behind it, those are industry standard size modules, as well as being pre-certified for most markets. So the idea being is if you want to go and build your own bespoke bit of hardware, and you want to put on an Azure Sphere onto that, you would go to one of these module providers and say, hey, look, I want a job lot. I want 300 of those modules, and I'm going to go and manufacture those PCBs. And the final layer down here is what are called Guardian modules. And the idea behind Guardian modules is that they're kind of off-the-shelf modules that you can customize. And the typical scenario where you'd use this is where you want to go and securely internet enable existing hardware. So for example, Divvy Parking are internet enabling their car parking solution, but you might have a manufacturing solution. Maybe you've got a lathe, or some sort of hardware that you're running in a factory that you want to internet enable, and you want to do it securely. So that's where you would go and use a Guardian module. And there are a lot of Guardian modules out there in the marketplace now, and they kind of all have different styles of connectivity. So the Divvy Parking one, which you're going to talk in a moment, they kind of expose off GPIO, so you can go and turn on a light or open a boom gate or detect security and things like that. Avnet have a board over here. Now, this board was used by Starbucks to internet enable their coffee machines. And so what Starbucks have done in the US, and this is they've just started their rollout, is they've got these devices which just sit on their coffee machines. Those coffee machines have both an Ethernet port on them and a USB port on them. And this AVNet board can interface into those coffee machines with that. And then Starbucks are doing things like loyalty programs. Hey, look, you've just bought a cappuccino. Would you like to go and buy a donut or something along those lines? There's another company out there called QIO, and they've brought out a cellular-based Guardian module. So that's kind of the ecosystem. So the next thing I want to talk about is what Divi Parking have done. So this is what I love about this is it's a real solution, and it will kind of give you a bit of a sense of what they're doing. So as I said, this is a video, so I'm cheating, and we don't have Peter here in real life.
There's no audio.
Can you not hear it?
No, there's some those working earlier, not now.
Okay, let me just pause this. And what I'm going to do, sorry about this, I'm just going to reconnect my desktop. This will just take a moment.
Thank you, Dave. Welcome, everyone. My name is Peter McAlpin, and I'm
Is that better?
Operations Director here at Divi Parking.
Yep.
We've built an enterprise-grade parking management solution with features for owners, tenants, and the public, all built on Azure platform that provides us with the security and scalability that is demanded these days. This helps us securely provide parking to over 30,000 people a month, plus provide insights from all that collected data. When we come to the installation in the buildings, we come across some very old school technology. Some even predates the internet. WCAN protocol, for example, which is used in many swipe cards, came from the 1980s and is still used today. Divi needs to work with this equipment and run control cables between all this across car parks, maybe up to 50-metre cable runs. But replacing this with a wireless device from a local electronics store probably is just a backward step. As Dave mentioned, from the fish tank scenario where somebody could just sit there and wirelessly hack away and nobody would notice. Whereas with conduit, you could see them pulling apart and hacking into cables. Internet of Things. It all sounds really cool. And there's lots of things on the market. Some have internet even. But when you think about the big data, analytics, automation, and security, I'm not convinced that some of these things should wear the IoT nameplate. And that was the problem we faced when looking for a solution of where we went next with our product. Divi didn't want to add another disparate technology with all the issues that brought. We just wanted a device that easily connected to Azure with a couple of built-in relays and inputs ready for connection. At that time, Azure Sphere had just been released for developers. It has high levels of inbuilt security, an easy SDK to make the connectivity to IoT hub really straightforward, and it just becomes an extension to the existing Azure infrastructure that my team already know and loves. Perhaps you could replicate some of this on a Raspberry Pi, but not to this level and scale. The end result, I now have a device that is easy to manufacture. My install has less cabling, which means less cost and complexity, and monitoring and maintenance are far simpler as it's all just straight built into our Azure ecosystem platform. Which brings me to my next slide. Azure Sphere is really just an extension of the Microsoft Azure ecosystem. It made it an easy decision for Divi to select this path and start making smart, secure buildings a reality. Imagine the future of smart cities, smart buildings. Currently, city buildings are probably sitting empty, hopefully not for much longer, but I suspect the aircon and the lights are still on during the day. What if a facilities manager could log into a portal and check this? He could then remotely shut down unnecessary electrical equipment. He could go further and set up alerts on the building entry and workflows to bring equipment back online automatically, all without leaving the safety of his home. Collaboration is a big part of making this world a better place. As shown in this slide, the Divi controller is just a piece of that puzzle. And we designed it exactly that way to be a piece of our puzzle, or even a piece of your puzzle. If that might be you, get in touch and we can share some ideas. If you want to know more about making your parking more efficient or Azure Sphere, please get in touch. Thank you for listening. Back to you, Dave.
Thank you for that.
Thank you, Dave. Welcome, everyone.
We won't have him again. So hopefully that kind of, the thing I loved about that is that we've actually got a Microsoft partner who's actually building a real solution on Azure Sphere as part of their overall secure parking solution. Okay, so the next part here is more technical and developer oriented, and we're just going to talk a bit more about developing applications. So just to kind of give you some sense of what you can use. So you can go and build Azure Sphere applications from Windows 10 or Ubuntu 18.04. The developer tools are free. If you're building on Windows, I recommend you go and use Visual Studio, but you can use Visual Studio Code as well, or you can go and use a command line. You can't use a command line if you want to go and integrate it into your tool chain. It's got a fantastic debugging experience out of the box, and I'm going to show you kind of how that works in a moment. Okay, so the demo that I'm going to do is using the Azure Sphere AVNet board. And I'm going to be using Visual Studio, and I'm going to be using IoT Hub, and I'm just going to show you a debugging scenario. Now, as I mentioned at the beginning, the demo I'm going to do is you'll find available, at that link, so aka.ms/Azure Sphere Developer Learning Path. And you'll find a whole set of labs there you can go and walk your way through to understand a bit more about building applications for Azure Sphere. So what I want to touch upon before I do the demo is just a bit of the architecture of the Azure Sphere, so kind of give you a bit of a sense of what's going on. Now, I mentioned before that the Azure Sphere Silicon is a multi-core microcontroller. Now, the cores that are highlighted in red, those are the cores where you can go and run your applications on. So there are 3 cores where you can go and run applications. So there are 2 core Cortex M4s, and on those cores, you can go and run real-time applications. So it could be bare metal applications, or it could be something like FreeRTOS, and very soon it's going to be Azure RTOS, which is basically ThreadX, which we acquired a while back. And you'll be able to run Azure RTOS applications on those cores as well. And the other core where you can go and put your application is on the Cortex A7. Now, the Cortex A7 has a number of responsibilities, and not only running your application, but also some operating system responsibilities, which I'll talk about in a moment. Now, there is another core over here, and this core is responsible for networking. So out of the box, there's Wi-Fi, but there's also Ethernet, and you can expect to see cellular, as I mentioned before. And we've also got another core, which is responsible for the security. It's a security subsystem. And then we've obviously got flash, and then we've got RAM. Now, the other thing about this slide is you'll notice that there is firewalls everywhere. Now, when you talk about firewalls on Azure Sphere, it's used quite broadly because firewalls are there for pretty much everything. So for an Azure Sphere application to be able to do anything useful, you need to whitelist it. And the idea behind that is if someone was able to get into that device, they couldn't get past the resources that have been whitelisted. So for example, you have to whitelist GPIO. If I want to go and use GPIO on this chip, I need to make sure it's been allocated to the application. If I want to go and use I2C, again, the same principle, I need to go and allocate it or assign it to the application. And I'm going to show you that in a moment. The same thing is for network endpoints. So this device cannot talk to any network endpoints without them being whitelisted. And the idea behind that is it stops anyone, if someone did kind of hack into this device and got sort of partial control of it, they would not be able to access other resources. So if you're familiar with the botnet attack that happened in the US, what happened there, that there was hackers that hacked into security cameras. And then once they're into those security cameras, they then did a denial of service attack on the east coast of the US DNS, and basically a DNS service, and brought down the DNS servers in the US, basically brought down the East Coast internet for a day. And so what we're talking about here is that these devices, if you could hack into them, you cannot get past the whitelisted resources. And that's kind of fundamental to what's going on. So this is a bit more detail on the architecture. So I appreciate there's a lot going on in this slide. I'll just kind of walk us through. So in this middle section here, we've got the Cortex A7 core. And the Cortex A7 core runs a number of services. So the first thing about this Cortex A7 is it's built on a custom Linux kernel. It's actually built using Yocto. On top of that, there are a number of system services. So there are things like authentication, there's over-the-air update, there's application management. So for example, you might want to go and push out a new application to the device that will manage that. Maybe the application crashes or it's been hacked or something's happening to it. That'll be reported back up to the Azure Sphere security service. And there's things like network management to make sure there's a connection and things like that. And then on top of that, you can go and put your what are called high-level applications. Now, interesting enough, you go and build a POSIX application. Now, clearly, there's not the complete POSIX API that's built into this microcontroller. There's just enough APIs to be able to go and build useful applications. And there is basically a C API for things like HTTP clients, there's GPIO, there's libraries in there for Azure, etc. So the key thing about that is that when you're building a high-level application, it is running on this core, which is competing with other things that are running on this core. So that means it's typically not a good candidate for IoT applications which are really timing sensitive. That's the main thing about that. If you have an application that's super timing sensitive, then what you do is you put those onto the Cortex M4s. So there are two Cortex M4s, and this is where you'd go and put your really timing sensitive applications or sensors onto those cores. Now, the thing about those cores as well is that they are completely isolated from the internet because they're not deemed to be secure enough for the platform. Now, the way that these applications talk is that these applications talk across to the high-level application across a messaging system. It's like a mailbox. So the high-level application, for example, could send a message to the real-time application to say, hey, I want you to go and measure something. And then the real-time application would go off and do that measurement and then return the result back to the high-level application. So that's kind of fundamentally how it works. Now, the demo that I'm going to show you is I've got an Azure Sphere. I'm going to build an application, which is a high-level application, which remember is going to be running on the Cortex A7, which is running on that custom Linux core. I need to define a manifest, and that manifest has a whitelist of all the resources that this application is going to use. And I can whitelist resources, hardware or peripheral resources, as well as network endpoints. Now I'm using IoT Hub, and I'm going to be using device provisioning service. So the device provisioning service is like a helper service. It's kind of a zero touch. So you can have a device talk to the device provisioning service. The device provisioning service says, I know who you are, I trust you. Here's a connection string that you can now talk to Azure IoT Hub. So that's kind of the handshake that goes on. Okay, so what I'm going to do now is a demo. Now I'm going to bring up a web page. So I've got a website that you can have all access to. As I mentioned before, this is up on the Azure Sphere Developer Learning Path, and you'll see the notes that I'm going to go through as I talk through that. And I'm also just going to start up the Azure portal, and we'll get that warmed up. And we'll just sign in. And while that's happening, and I'll just go across into the resources that I want. So in Azure, so I'm in the Azure portal, and as I mentioned before, I've got two services sitting up inside Azure. I've got the device provisioning service, and I've got the IoT hub that this device is going to talk to. By the way, what I didn't touch upon is that in the Azure Sphere, there are built-in libraries for talking to IoT, so Azure IoT. There is nothing to stop you building an application which talk to another cloud provider, or for that matter, to your own systems that you might have in-house, or ones at home, or whatever it is. Kind of out-of-the-box experience is great for Azure IoT, but there's absolutely nothing to stop you using this for other platforms as well. So what I'm going to do now is just go into Visual Studio. So the first thing I'm going to do is I'm going to whitelist the resources. So I'm going to go into this thing called the app manifest. And you can see in here that I've got a few resources highlighted. And I'm just going to, the first thing I'm going to do is actually just go to the web page, and I'm going to paste in the peripheral resources that this application is going to be using. So I've got access to an LED, so it's basically a GPIO, which I've tagged LED, and another GPIO, which is a relay. And this application is also using I²2, so I², the bus. And the other thing is I'm going to allow us some access to some resources. So in this case, I need it to be able to talk to the device provisioning service. So I come up to the device provisioning service. You'll see that there is an endpoint. I'm just copying that, and I'm going to paste that into there. And I'm just going to jump back to my demo device provisioning service and paste that endpoint. And then the other endpoint that I need is the endpoint for the IoT hub. If I don't kind of whitelist these endpoints for these resources, the Azure Sphere won't be able to talk to the Azure IoT, and obviously the application is going to fail. So that's the first part. So that's the kind of the key thing about Azure IoT, is that you need to be explicit. By default, the Azure Sphere device is locked down, and you need to be extremely explicit as to what devices that you're going to be using. So the first thing I'm going to do is paste in some code into main.c. And I'm just going to talk through some of this code. As I said, all this code is sitting up on that Azure learning path, Azure Sphere developer learning path. So the first thing I'm defining is what's called a timer. Now, timers is typically the model. So you tend to kind of build this event-driven model, and you use timers. So a timer will fire, and then it'll call a handler. So in this case here, what I've got is a period set for this timer, and it's going to fire every 5 seconds. And every time it fires, it's going to call this C function called read sensor handler. And you can see the implementation here. And what it's going to do, the first thing it does is just basically takes the event off the event loop. The next thing it does is it reads the telemetry off the built-in sensor on the AVNet board. And then I'm going to display that in a debug window. And then I'm going to send a message to Azure Sphere. And the next thing I'm going to do is I'm just going to paste in a bit more code. And I'll just talk us through that. So this next bit of code, what I'm going to do is I'm going to use something called a device twin. Now, a device twin is a JSON document that's managed by Azure IoT Hub. And what it is, it's a mirror image of the data and the state on the device held in the cloud. So the idea behind it is you can go and set a device twin property, and then IoT Hub will mirror that data down onto the device, and then the device can respond to it. That device can also do what's called a device twin update, in which will send a message up to IoT Hub, and then will update this JSON document. With the data in the cloud and these JSON documents, then you can go and write server-side applications which query those JSON documents. For example, you might say, I want to query all the devices in my network where the relay is turned on. That's the kind of thing. And obviously it wouldn't be practical to try and do that in real time. So you have these devices report their state up into the cloud, and then you can go and build an application which queries that data. So I've got a twin property in here called relay1. So remember that, because I'm going to come back to that. It's of type Boolean. And then when this device receives a device twin message from IoT Hub, it's going to call this handler called LED1 control handler. And you can see down here, what it's going to do is it's going to turn on a light on and off, depending on what the state of that is. So the first thing I'm going to do is I'm going to start this application running. And what this will do now is it's obviously going to build the application, and it's going to copy the application across into the device. It's going to copy across the debugging symbols, and then it's going to attach the debugger. And we'll talk a bit more about that in a moment. So you can just see it's copying across the symbols, etc. Now, the next thing I'm going to do is I'm going to, whoops, I forgot a step, and it's kind of crucial. Sorry about that. I need to initialize those resources that I've just set up. And in here, you'll find that these are sets, and there's just some helper functions which just make it quick and easy to go and initialize the sensor, the LED, and the device twin. Sorry about that. So now I'm going to run that and deploy that onto the device. I've got everything there. Okay, so while that's starting up, I'm going to go across to Azure Sphere, the Azure portal, and I'm going to start up the Cloud Shell. And this will just take a moment. So the Cloud Shell, if you're not familiar with it, is a pretty useful way. You can start up a Bash shell or a PowerShell up in the cloud, and it has the Azure command line tools already pre-installed and kind of managed and updated for you. So that will just take a moment. And actually, I'm just going to, it's already started, and I just want to get past that breakpoint. Okay, it will be there in a moment. Okay, so it's started. And what I'm going to do is I'm going to paste in this command. So this command here is going to monitor events that are coming from the Azure Sphere device that I've just started. So you can see the telemetry coming in from the device. And what if I just going to make this a bit sort of half screen, and I'm going to start up the output window, and I'll just jump back to the portal so you can see both on the screen at the same time. Okay, so you'll see down here inside Visual Studio, you can see that I've got the output from the debug statements on the Azure Sphere. So you can see there goes the temperature. It's a bit of JSON. And if I jump back to the portal, you can see that the telemetry is going up to the portal. Okay, so the next thing what I want to do is show you how to work with the device twins. Now, the first thing I'm going to do is I'm going to set a breakpoint. Sorry, I had a breakpoint there before, and I had meant to unset it before I did the demo. So I'm going to go across to the Azure Sphere portal, and we'll just minimize that down. And I'm going to go into IoT Hub, and I'm going to scroll down to my IoT devices. And in this hub, I've got 2 demo devices. I'm going to select this one here, which I know is that device. And what I'm going to do now is I'm going to go to the device twin. So remember I said before that the device twin is a JSON document that represents the current state on the device. And the idea behind this is, I know this is not that easy to see, but you'll see that I've got 2 main groups of properties. I've got what are called desired state and reported state. And what I'm going to do is I'm going to set the desired state on this device. And in this case, you remember I said to you before, there was a property called relay1, and I'm going to change this to be true. Now, I just want to point out one thing. I'm doing this by hand. Clearly, you would have an application that would manipulate, and there's a set of APIs for managing the interaction with the JSON document, with the IoT Hub JSON document. But I'm just showing you so you can kind of see what's going on at a lower level. So I'm going to save that. So what's happened now is that IoT Hub took that device twin message and sent it down to my device. And then my device, you remember up here, I've set up this thing called device twin binding. And I had a twin property here called relay1. And what you can see now, it's hit the breakpoint. And now I can just step through. So I'm just going to use the F10 to step over this. And we'll go, and now we're going to turn on. If I hold this up in front of the camera, you can see, if you'll be able to probably see down the bottom, if I step over that, you'll see it's turned on the light. And we'll jump through that. And if I jump back to the portal, what I'm going to do now is do a refresh. And you'll notice it down. Just make sure that goes through. We'll do a refresh on that. And you'll see that now the reported state of this twin is now, for this is now true. So it's basically what's happened is a device has received this twin property, it actioned it, it turned on the light, and then sent back a reported property. If I go and change this to false, and again, I'll just hold this up in front of the camera, set the breakpoint, jump back to my code. I'm just going to hit run. You'll see it's turned the light off. So that's kind of how you can use device twins with these devices. Again, most SDKs for Azure IoT support this concept of twins and direct methods. But I just want to kind of give you a sense of the debugging experience behind for building applications. Okay, so that was a demo. We're just going to jump back to the slides. Okay, so the resources for this session. So you'll find up in the tech communities, if you go hunting for Internet of Things tech community, you'll find there's a whole stack of blog posts that get updated here on a fairly regular basis. There will also be a number of postings there after build, which happens next week. You can find more about Azure Sphere at just search for microsoft.com/Azure Sphere. Information on pricing, information on get starting, and information on support. As I mentioned a couple of times, you'll also find the Azure Sphere Developer Learning Path at that link. And you can follow me on Twitter. And I put all my source code up onto GitHub. So it's all open source. Super happy if you guys want to get involved in it and contribute to it, or if you find issues with it, raise issues. So just github.com/gloveboxes. So pretty easy to remember. So that is a session. So hopefully that kind of gave you a bit of a flavor of what you can do. And now, if there are any questions, we just jump over to the questions, and I'll just have a quick look down through there. So thanks, someone's put. Yeah, so self-driving cars, or I would put, someone said that would be a super example of something that needs really quite precise timing. The other example that I've seen where you're running on these M4 is when you want to run machine learning models. So these devices are quite capable of running what are called tiny ML. And there's some quite nice examples floating around where you can actually push tiny machine learning models onto these. So for doing things like voice activate, so the kind of hey Google or hey Siri or all those types of scenarios, you could go and build on this, and it'd be kind of cool to be able to put those kind of models. Now, can we use Azure Sphere with so the question is there, can you use an Azure Sphere with a Raspberry Pi or an Arduino? And the answer is yes. And there's some quite nice examples of that. So in some respects, what you're doing there is you're using Azure Sphere as a Guardian module. And the way you typically do this is you'd normally just use either UART or I2C, I2C, and you would just have messages going backwards and forwards between the Raspberry Pi and the Azure Sphere. So the Raspberry Pi can be an I2C slave, it can't be a master, but the Azure Sphere can be an I2C master. So that would be a super easy way to go and pass messages between a Raspberry Pi and Azure Sphere. And exactly the same principle would apply for an Arduino. You would just get to set up a protocol between the two devices and have them swap information. And then you would have the Azure Sphere either do some work or forward that information onto the internet somewhere, what is your kind of endpoint for that. So hopefully I answered that question, Kunal, I think it is. Are there any more questions? Hey, that's a pleasure. Cool. And yeah, it'll be a fun project. So if you do it, please tweet me and let me know what you've done. I'd absolutely love to see what you've done. So as I said, it's at @dglover, and what's this here? I have an Avnet Sphere starter kit. Can it be used as a honeypot? It kind of wouldn't make sense to use it as a honeypot because it's such a locked down device. I'm trying to think how to say no. I hadn't thought about that one, I have to confess. Could you use it as a honeypot? So I guess what you could do, if you wanted to kind of do an interesting experiment and put it out there and make it a hack, try and hack this device, that'd be kind of cool. I don't quite know if that's where you are coming from. Could you use kind of like make it a hacking? Now, these devices, by the way, have been through a lot of hacking. So the guys go to take it to a lot of the hacking conferences, and it's been a lot of work has been done to make sure it's bulletproof. And the whole idea behind Azure Sphere, as I mentioned before, security is absolutely a journey. And as we detect new attack vectors, the whole concept behind this is that we provide the ability to go and update that device, as well as you can update that device. So that's key to the reporting. So we basically, on aggregate, for all the Azure Sphere devices around the world, if we start seeing that, that's interesting, we're seeing an attack vector trying to hack into these devices, we can now see what's going on across the internet, and then we can start making sure that this device is being mitigated against those attack vectors. So I hope that sort of answered your question. Hey, look, I'm sorry, I just don't know enough about those. But if you want to reach out to me on Twitter. Just add me on Twitter, and we can start up a DM and we can have a chat. Be super happy to talk a bit more about that. Love what you're thinking, and let's see what we can do behind that. Hey, it's a pleasure. Thank you. As I said, I'm going to do a couple more talks over the next couple of weeks. They're going to be actually more Raspberry Pi oriented. One's going to be building an air quality monitor. As I'm sure you saw in the news, Australia suffered from terrible bushfires, and Sydney and most cities were just covered in smoke. And behind that, what happened then, I went and set up an air quality monitor. That was kind of the inspiration for that. And I'll kind of give you a bit of a sense of what's going on. I do the demo now, and of course, with the lockdown, our cities are beautifully clean. And the other talk I'm going to do is about cognitive services, again, running on Raspberry Pi, and just show you what you can go and build around that. So, hey, cool. Thank you very much. I think we're probably pretty much at an hour. So thank you very much for everyone for hanging in there.
Perfect. Thank you so much, Dave. And thank you everyone for being there. And like I have already mentioned in the chat, that Dave is coming again on next Friday, so be there. And it's going to be a fun session, so you should be there to have some fun as well. And if you have any other questions, you can put it in the chat box, or probably you can tweet Dave directly the questions. I guess that will be fine.
Yeah, or for that matter, you're quite right. Put them in the chat. If you've got questions, I'll just keep an eye on the chat. Yeah.
Perfect. That makes sense then. Then I guess wonderful. We are on time. We have managed to close it in time. That's an amazing thing. So let's wrap it up with the same energy. And you guys have a great weekend then. And we'll catch up next week in Azure Happy Hours next session on Friday. Thank you so much, Dave. Thank you, everyone.
It's a pleasure. Thanks, everybody, and stay safe. And hopefully we'll see something next week. Take care.
Yeah.
Bye-bye.